So now each of these registered images are obtained by a rigid body linear transformation. Those rigid body linear transformations are also outputted by the ATRA program, and these are simply the file names with the suffix mrx. So these would be text files, and they would be v1 through 4 mrx. Okay, so 4 outputs will be the transformation matrices. Let's just look at one of these image files, transformation matrices. Let's say, let's just look at the third one. And this is simply a 4 by 4 matrix. And this matrix represents a rigid body linear transformation. So in addition, these 4 matrices are outputted in FSL format. So the MRX matrices are in ART format. The program also outputs the same matrices in FSL format, and these would be called the image name underscore FSL dot mat. So you can see that these 4 matrices are also outputted. The difference between the FSL and ART matrices is that in ART, the center of the field of view is taken to be at the origin of the coordinate system. In FSL, however, the corner of the field of view is taken to be the origin. Therefore, the matrices won't be the same, but you can convert from one to the other. So these 4 FSL matrices are also outputted and can be used along with other FSL programs. Okay. Then there are some files, precisely 12 of them, generated. These are PPM files. These are single slice images. They are mostly meant for error checking, but they can also be converted to JPEG or other formats and imported into your documents for publication, for example. So after this program is finished, what I will do is I usually look at these PPM images to see if there has been any errors. So for this purpose, I use the GIMP program. If you don't have the GIMP program on your system, I highly recommend that you install it. On most Linux systems, this is already installed. However, on my Macintosh, Mac OS, it wasn't installed and I had to install it myself. So let's look at these 4 of these PPM files using GIMP. I usually look at the Orion, the images that have the word Orion in their name. So, okay, so as you can see that these Orion images essentially show the mid-sagittal plane of each of the 4 input images, and on the mid-sagittal plane you can see 8 automatically detected landmarks, which we call the Orion landmarks. And so the one landmark, for example, as you can see here, is the most anterior point of the corpus callosum. This is the anterior commissure. This landmark is the vertex of the superior pontine sulcus, and so on. So from here we can see that in this example the 8 landmarks on each of the 4 images have been correctly located. Now, if something had gone wrong, you would have seen that there is some problem. One of these images would not be right, and then you would have to correct that. So let me now close GIMP. All right. So now there are 5 other text files which have the .text extension. These 4, which has the name image name underscore acpc.text. Let's just look at one of them. So this is a text file, and it shows the estimated mid-sagittal plane for the volume. And it actually gives you the equation for that plane. So as you know, the equation of a plane in 3-dimensional space is ax plus by plus cz equal d, and this is precisely given in that form. And the a, b, and c are direction cosines that specify the orientation of the mid-sagittal plane, and the d is the distance between the mid-sagittal plane and the origin, which in case of art is the center of the field of view. This file also gives you the location of the VSPS landmark, the AC and PC. And the other file, which is named your output prefix.text, essentially is a file that the first line is the number of images, the second line is image 1 followed by a scale factor, and the third line is the matrix for image 1, is the registration matrix for image 1, and then lines 3 and 4 and 5 pertain to image 2, and so on. These scale factors indicate that these images have different scale values, and that's why when we average them, we have to use these scale values to create a weighted average. But anyhow, this file is meant to be inputted to other programs. So for example, the Kaiba program or Yuki program in the automatic registration toolbox will directly read this file and will be able to work on registered and scaled images. Okay, so in the next tutorial, I am going to go over a case where the landmark detection fails, and show you in such cases how to remedy the situation. Landmark detection fails in around less than 5% of the cases. So roughly about in 1 out of 20 images that are run, the landmark detection fails. Therefore, we have to specify some of the landmarks manually and uh, restart the program. So in the next tutorial, I will go over this procedure.